Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic probability. In the previous video, we solved a question on finding the probability of an event after tossing a coin. In this video, we are going to solve a question on finding the probability of an event after rolling a die. The question for this video is: two fair dice, each with faces numbered 1 to 6, are thrown together. 1. Construct a table showing all the possible outcomes. From the table, find the probability that I, the two dice, show the same number. The two dice show different numbers. 2. From the table, find the probability that the sum of the numbers on the dice is I 5, I 10, I at least 10. So here we have two fair dice and each one of them has its faces numbered 1 to 10. And we are supposed to construct a table to show the possible outcomes. Then from the table, we will find the probability of these events that has been given to us. So we know that the faces of the dice are numbered 1 to 6. Let's represent the first die with D1 and represent the second die with D2. To help us find the set of possible outcomes, we are going to draw this table here. We will use the first column to represent the first die and the first row to represent the second die. Remember that each of the die has its faces numbered 1 to 6, as we can see from the table. So we are going to combine these two to get the set of possible outcomes. For the first one, we have 1 on the first die and 1 on the second die. So we have 1, 1. In the second case, we have 1 on the first die and 2 on the second die. So you have 1, 2. When you come here, you have 1, 3. You have 1, 4 here. You have 1, 5. And you have 1, 6. Now, when you come here, we have 2 on the first die and 1 on the second die. So you have 2, 1. When you come here, we have 2 on the first die and 2 on the second die. So you have 2, 2. Here you have 2, 3, you have 2, 4, 2, 5, and 2, 6. When you come here, you have 3 on the first die and 1 on the second die. So that will give us 3, 1. We have 3 on the first die and 2 on the second die. So you have 3, 2. When you continue, you see that you are going to get 3, 3, 3, 4, 3, 5, and 3, 6. You do the same thing for here. You are going to have 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. You do the same thing here. You have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. And finally, you have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. This means that when you roll two fair dice together, these are the set of possible outcomes. When you count them, you are going to get a total of 36. It means that our sample space is 36. The first question says that we should find the probability that the two dice show the same number. So the event we are looking for here is the same number. Now this is our table. So we are going to look for the members with the same number. They are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. We have 6 of them. So 1, 2, 3, 4, 5, 6. It means that the number of members in this event is 6. So the probability is 6 divided by 36. And when you simplify this, you are going to have 1 divided by 6. The second question is, find the probability that the two dice show different numbers. So here the event we are looking for is different numbers. This is our table once again. We can see clearly from this table that if we cancel out the members with the same number, that is, if we cancel out 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6, all the remaining members will have different numbers. All the remaining members will have different numbers. We have cancelled 6 of them out. The total is 36. This means that the members with different numbers is 30. The members with different numbers is 30. So the number of members in this event is 30. Our sample space is 36. So the probability is going to be 30 divided by 36. And when we simplify that, we are going to have 5 divided by 6. The next question is, find the probability that the sum of the numbers is 5. So here is our table once again. We look for the members that when you add them, you are going to get 5. They are 1, 4. When you add them, you get 5. 2, 3. When you add them, you get 5. 3, 2. That one also, when you add them, you get 5. And 4, 1. When you add them, you get 5. These are the only members that when you add them or when you sum them, you are going to get 5. We have 4 of them. So the probability is 4 divided by the total, which is 36. And that will give us 1 divided by 9. We are looking for the probability that the sum of the numbers is 10. So here's our table once again. We look for the members that when you add them, you are going to get 10. When you add them, you are going to get 10. So we have 4, 6. We have 5, 5. And 6, 4. When you add these members, you are going to get 10. We have 3 of them, so the probability is 3 divided by 36. And when you simplify this, you are going to get 1 divided by 12. The last one, we are looking for the probability that the sum of the members is at least 10. That is 10 or above, at least 10. So 10 or above. So we have our table once again. We are looking for members that when you add them here, you are going to get 10 or above. We have 4, 6. When you add them, you get 10. We have 5, 5. When you add them, you get 10. We have 6, 4. When you add them, you get 10. We also have 6, 5, because when you add that, you get 11. It satisfies this event. We have 5, 6, and 6, 6. We have 6 of them, so the probability is 6 divided by the total number of members here, which is 36, and that will give us 1 divided by 6. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the probability of an event after rolling a die and tossing a coin together. Bye-bye.